morning, everyone. My name is Reagan Sokolowski, and I'm a marketing specialist too with ESC Spectrum. Thank you so much for joining Evaluating Your CEMS with our CEMS Integration Manager, Bobby Greenwald.
Good morning. So as Reagan said, my name is Bobby Greenwald. I'm the CEMS Integration Manager for ESC Spectrum here in Pensacola. So you inherited your CEMS. Now what? First thing to say is you're not alone. This is a fairly common problem now, especially with acquisitions, retirement, and staff turnover. So you're looking at your CEMS, you've got them, you've inherited them. Now, how do you figure out what you have? So the first thing to do is to make a list, take stock. What do you have? Now, I acknowledge that doing this sounds simple at the beginning, but not necessarily. Some of your equipment may be in the shelter, some of it may be out in the plant, may be on a duct. So really take inventory. If you don't know where to start, some good places to start would be by looking at your QA/QC manual. Everything that you have should be listed in your QA/QC manual. Another good place, if you're Part 75, is your monitoring plan. It should list all the equipment that you are using to monitor your CEMS, along with the models and serial numbers. And if you don't have either of those, or even after you've had them and looked through them, go ahead and walk down the CEMS shelter. Write down all of your serial and model numbers, take photos so that you can see what this equipment is, and make a list. Some of this you may have to go hunting for. You may have to enlist some plant personnel to help you find it. Your probes, your flow monitors, your opacity monitors are likely to be up on a stack or a duct somewhere. And those photos that you take, good thing to take pictures of are not only the serial numbers, put some wide angle views so you can really see what it is that you have. And about that QA/QC manual, this is probably the most important slide in this presentation. Your QA/QC manual is your quality assurance, quality control manual. It describes your CEMS and how it is maintained. Just a point of mention is if you do have an audit or an inspection from the state or the EPA, this is typically the very first thing that they're going to ask you for, because they are going to want to know that you have one, that it's up to date, and that you're actually following it. So when you look at this manual, the first thing you want to check is, when was it last updated? It should be dated. It'll want to show that it's used and reviewed. The second big item to check is, does it match your equipment? Does it actually call out what you currently have? Did it catch your last upgrade that you did? Did you change any equipment out? You want to make sure that it matches. And then the third thing, and I can't emphasize this enough, is, does it actually describe the practices that you do? So if you have a maintenance procedure in your QA/QC manual and you have an inspection, a lot of times they will actually ask you, tell me how you do this. And they want to make sure that it matches what you actually do. So this is an excellent place to start in making sure that it's up to date and accurate. So now that you've had a list, you've got your QA/QC manual, the next best thing to do is take a comprehensive evaluation of where you are at. Some of the big items to look for is any of the equipment obsolete? If you don't know if it's obsolete, that's where those model and serial numbers come in. Being able to go back to a manufacturer or an integrator. We've done some, in fact, on the next slide, I'm going to show you a sheet that we use. But you can actually call the manufacturer and say, hey, I have this model. Is it current, up to date? Has it been obsolete? Can I still get parts for it? That is one of the most important things to look at. The second thing would be, what's the condition of the equipment? Is it well maintained? Is it showing its age? Really overall, what does it look like? and how long has it been in service. Now, the condition and the service, there are a lot of factors that affect how long something's going to last for you. Your flue gas composition, basically the more harsh your flue gas is, the shorter runtime that you're going to have on it. Just in general, a extraction system that's pulling pure flue gas through it is going to last not as long as something like a dilution system that's 100 to 1, where it hasn't been subjected to as much of the harsh components in your flue gas. Next one is run hours. Something that's run 365 days a year, 24/7. Years-wise, is going to have a shorter life on it than something, a unit that runs not quite as often. And then, of course, the other big one are the maintenance practices. The more preventative maintenance that you do on your units, the better those maintenance practices are, the longer your equipment is preserved. And here is our comprehensive checklist that we use for site walkdowns. If anybody wants a copy of it, our contact information's here. You can ask us, we can give you a blank one. But this is really where we'll go and do a site walkthrough. And these are the things that we're going to look to find. One, we're going to make a list of everything that should be there. And then what the make is, what the instrument is, what it's measuring. What it's measuring is very important when you go to replace it, because it'll tell you, what's going to be down while it's in replacement, and then where it is, so that you can find it in the future, and the next person coming to look at this will know where it is. And then there's your model numbers. The next thing you put down is all your model numbers, and with those, you are able to go back, look to see, what the obsolescence date is. Almost all CEMS manufacturers do publish those. And then your serial numbers. Those, and if you're Part 75, those serial numbers are required, and they should also be inside your QA/QC manual. And your monitoring plan. These serial numbers, if you need information, for example, on your opacity monitors, your setup information, almost always they're kept on file somewhere. So if you have that serial number, that's a good place to start if you don't know, where to start when you have to replace it. And then when you put it in, as you notice on this sheet, not everybody can figure out when they put that in, and that is okay. At least you have a start in place. And then we use a 1 through 5 grading system. 5, it's brand new, perfect condition, just installed, good. No need for it to be replaced anytime in the near future. Fair, it's okay, it works, but you need to look at replacing it in the near future. And then 4, you're having maintenance issues. It's causing some downtime. It's getting you by, but it's not good. And critical is, it's failing, and it needs to be replaced immediately. And so by creating the list, the other big thing about this list and making it is that having this comprehensive list allows you to go to management and allows you to plan. Because a lot of these, I understand that you may be on a 5 or a 10-year budget cycle where you have to get these replacements into your budget. This is a good tool to track them and to let management know what it is that you need to get replaced. So spare parts. First of all, do you have a spare parts list? On the spare parts list, you're going to have typically 4 levels. The first one's going to be your consumables. Those are your filters, your O-rings, your gaskets, the things that you may be changing out depending on your situation. It could be a week, a month, a quarter, or even a year if you don't run very often. So those are the things that are just normal things that you change out. You want to make sure that you have those on hand at all times. Level 1 is your normal wear and tear. These are things that you're probably going to look to change out at least once a year. Things like pump rebuild kits, peristaltic pump tubing, just things that just normal in contact with flue gas, normal mechanical wear, they are going to wear out on you. Level 2s are your common replacement parts, things that have a tendency to need to be replaced, that fairly common replacement items. And level 3, these are your major components, things that aren't typically they're not common failures, but they are things that that could fail, and they are change it. You can change them out. And then with that spares is taking stock of what spares you have on hand. Do you have all your consumables either in the warehouse or out in the shelter? If you don't know where they have saved your spare parts, very common is for them to be in a warehouse and inventoried. Others will keep them out in the shelter, especially the consumables or the level 1s. They may have been purchased with a project. And then, the other option is if you have multiple facilities for some of those level 2 and level 3 that may be higher dollar items that you don't want at every plant. There's a lot of places that have a common storage and and they share them out. So that is an option as well. And the third one is spare analyzers. So spare analyzers, especially if you are on a Part 75 system, 30 days, you do have a year, you do have the option of using a like-kind replacement. And keep in mind that like-kind is the same technology. It does not have to be the same make and model. So say you are running a thermo 42 NOx analyzer and you had a failure, you can't get it back up, you're down, but a neighboring plant has a spare TML 200 analyzer that meets your needs. That still can be considered a like kind. With the supply chain and the longer times of getting spare parts, the one thing that I would recommend is if you can have spare analyzers, you being able to use that like kind replacement can save you a lot of downtime, because they can run while you're trying to get a part. If the situation is enough where you've had a failure, you can't get the spare part. Now it is expensive to do the RADA, but you can RAD it, leave it in, and and continue on. And then when you fix your other one, it can be you can use that as a spare. So spare analyzers, the thing about them is that when you use them, you want to make sure that they're ready to go. So having a plan to keep them on the shelf and periodically test them. And then after they've been used, is making sure that they are cleaned and serviced before they are put up on the shelf. One of the things that people may forget about is that if you run flue gas through an analyzer and don't get it completely clean, change out the O-rings, filters, gaskets, that flue gas can sit in there and it can corrode those things if it sits long enough. So you'll want to make sure that you get that all clean, or you run it on clean, dry air for a while before you put it on the shelf. And then, like I said, best practice is to occasionally take those spare analyzers and fire them up, make sure that they're good to go. Because if you do have a situation in the field where you need to use one, it's always great to make sure that you have confidence in that your spare is going to really get you through the period of time while you're fixing. The other one is documentation. We've already talked about the QA/QC manuals, and then also making sure that it's up to date, that it's accessible, everybody knows where it is. Whether you keep a paper copy in the shelter or you have a computer where it's a shortcut on your desktop, anywhere it can be accessed very easily. Your user manuals, those are invaluable. And of course, you usually don't need them until it's about 2 in the morning and something's broken and you're being asked to fix it. And then you're searching for it. So keeping those user manuals, either the electronic versions, like I said, on a desktop in the shelter, or having them physically printed there, making sure that they're there before you need them. So those user manuals, make sure they're available before you need them so you're not searching for them when you need them. Procedures. Procedures, there are some procedures that are required by the EPA to be in your QA/QC manual or as an attachment to it. But all your common procedures, make sure that you know the proper way to run a cow. Any of your standard QA tests that you need to do. Make sure you know how to do your linearity or CGA, that you know the proper way to do a system response check and an abbreviated system response check. That those are documented for you, and then also the common procedures for standard maintenance tasks. A lot of those are available for your analyzers inside the user manuals. I know a lot of people do refer back to their user manual rather than reprinting the procedure. They'll say it's in chapter 8 inside TML manual. And a lot of those manuals are very good. They're step by step and tell you exactly how to do a particular maintenance procedure. In the back of those user manual, there's usually some troubleshooting to help you pinpoint some issues. Prints. Prints are invaluable, but only if they're correct. And once again, a lot of people don't think about their prints until they really, really need. Whether you have an IO, an output coming out of one of your analyzers that's going into an 8864 or into a DCS or PLC, and you're trying to find both ends of the wire. And of course, this never happens at a convenient point. It's 2 in the morning, Christmas Eve, and you just want to go home and get this done. So having those prints available and accurate. And then also the other thing about those prints is when you go to upgrade your CEMS, the first thing, whoever is doing your CEMS, whether it's internal project management or it's an integrator, whoever's doing this or an engineering firm, whoever's doing this, the first thing they're going to ask you for are where are your prints? Do they have a place to start? So having those will help you maintain and troubleshoot your system. It'll help also give you a starting point when you need to upgrade them. Your P&ID drawings, and those would be your piping and instrument diagrams. So in addition to the wires that go from your analyzers to your control system, you will also have piping and instrument diagrams that tells you how your whole system is plumbed and how it works. And those are also invaluable when you start having issues or when you need to upgrade your system. But also those P&IDs, they're great for training new techs and explaining to them how the system works. And then also when I said go ahead and take inventory, now if you're not 100% certain, you have an analyzer, but there's a whole bunch of other things hooked to it, and the only thing in your inventory is your analyzer itself. Well, if you have a P&ID diagram, it will actually show you everything that's in your system. And then from there, you can start chasing down physically where each thing in that piping and instrument diagrams is. And then the last one is communication drawings. These are probably the most common to not be documented. These will tell you, your IP addresses, where all your fiber goes, how things are, what is your data flow? Does it go from your instruments to a data controller or a PLC and then into the DAS? Is there also a fiber Modbus connection over to your DCS? How do you have it addressed? Because once again, when your communications go down or you need to make a change or an upgrade, knowing how your system's configured, especially if you have to bring IT in. You know, you know you have an issue, you're just not sure where it is. Things are not talking. By being able to pour over that communications diagram, it lets them take a look at exactly where you're at, so that they can communicate. And one of the other things very important on that communication diagram is the blocks that tell you where the equipment is. So it goes to their junction box. But is that junction box in the shelter, or is it, on floor 8 of the boiler building? And being able to find those ends instead of having to search for them when something's down. So really, all this documentation is the best thing I can say is to get the documentation together before you need it, so that it's all there, it's all in the shelter, everybody knows where to find it when they need it, so you're not scrambling. Some final thoughts before we go ahead and go to questions is just taking an evaluation of where your plant is. Do you have the expertise in-house? With staff turnover, retirements, do you need training? Do you have the manpower? Or do you need assistance? Do you need backup? So you normally have an INC tech or that takes care of your CEMS, but they've retired. Do you need someone to get you through? Can you get it from another plant? Do you need to bring an integrator in, or a field service team? Are you okay most of the time, but maybe you need some backup for vacation support? There's lots of ways to get that. Like I said, most of your integrators, including us, do those type of assistance. There's also other ways to get it from neighboring plants if you have more than one location. And then the final one is do you have the support numbers readily available? And by these support numbers, I would consider them internal and external, and labeling, what these support numbers can help you with. So internally, you may have a contact for your environmental contact if you have questions, if you have rule questions. You may have an IT contact that can help you if you have a communication issue. You may have a DCS contact that knows about the CEMS and the way they go into DCS. Other people at other plants that can help you troubleshoot. Then external would be all of your external support, whether they be ESC Spectrum with our field service. Just a little plug for us is we do have a 24/7, 365 number that we pick up for both our hardware and our software customers. And a lot of other people do as well. Most of the analyzer manufacturer have a support phone number that you can call. Typically, it's Monday through Friday during normal business hours, unless you've paid for a support contract. But having all of those numbers available, and most of those people are more than happy to tell you how the project works and help you move forward. So having them before you need them is fantastic. So that is the end of my actual slideshow. I don't know if we've had questions come in. I'm going to go ahead and turn it back to Reagan. But my closing statement here is simply, I put it through a lot of information here, is really going through and looking what you have, understanding what you have, getting all your documentation together, getting all your phone contacts together, all of your support together, and having it before you need. So that when you do have something come up, whether it's a malfunction, some downtime, or simply an upgrade, or you just want to do some continual improvements, you'll already have all the documentation and support that you need.
any other questions. So I think we might be good to go.
All right, well, thank you for taking the time to listen to us today. And like I said, my email is always open, and don't be shy to send any questions over.
Awesome. Thank you, Bobby, and thank you, everybody. I hope you have a great day.